So we're going to transition from what we've been doing into polygons. And in particular, we're going to spend a lot of time talking about four-sided polygons, but that comes later. Okay, so let's start with this. We've talked about polygons before. Remember polygon, poly meaning many, gon meaning, you might not remember that.
Line.
Sides. Okay, so close enough. The yellow, the green, and the light blue are polygons. Why are they polygons? Because all the sides are segments. It's a closed figure. And there's no overlapping of the segments. Each segment intersects other segments at the endpoints. So obviously, if you look to the right, the not polygons, the first one in the upper left is not closed. The one in the upper right crosses over, and then obviously the one in the bottom has a curved section, and that's not good. Okay? Good. So we knew that already. So what are the names of the polygons? Let's start with the purple thing. Leah, what's the purple thing called?
A triangle.
Outstanding. Originally referred to as a trigon. That's your trivia fact for today. That is, in fact, a triangle. Emily, B, what's the green thing called? The bright green thing?
Square.
No. That's a type of the green thing. What's the big term for all things like that green thing? Any idea?
I'm not 100% sure.
That's okay. Emma?
Maybe a quadrilateral.
It is a quadrilateral. Very good. Quad meaning four, lateral also meaning side. Okay, so from green, we go to puke green. What's that thing called? Lexi, what do you got for me? 5 sides, any idea?
Pentagon.
Outstanding. Happens to be the shape of that building in Washington. It is called a pentagon. Penta, 5. Gon, sides. The white thing is what, Bobby? 6 sides.
The white thing?
Yes, sir.
Hexagon?
Say it again, I'm sorry.
Hexagon?
Perfect. Hexagon. 7 is gray. Lorenzo, any idea?
No, not really.
Anybody? There's actually 2 answers that are acceptable. Hepta or septa? Oh, let's give somebody a gift. Elizabeth, what's the red thing called?
Octagon.
Good. Octagon. Stop sign. I forget if it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, yellow thing. Anybody in here? 9 sides? Nonagon. And then the pink thing or the magenta thing. What's 10 sides? Decagon. Whoosh. Beautiful. There's 2 others that you're going to be responsible for. 11 sides, which I think I have on there. Yeah, 11, 12, and N. So let me explain that. 11 sides. Un decagon. I'll write that down for those of you that are visual learners. Un decagon. Un, 1, deca, 10, 1 plus 10, 11. Therefore, Ainsley, what's a 12-sided figure called?
Oh, jeez. I don't know.
Let's review. Un decagon. Un, 1. Deca, 10. 1 plus 10, gon.
What?
Mia, you have to say it louder so she can hear you.
Did you hear me?
I can hear her over here, yeah.
Is it a what now? Is it what? A dodecagon?
There you go.
Thanks, man.
Do, 2, deca, 10, decagon. Now, we could keep going. I could spend the time to teach you all the Greek prefixes. 13, tridecagon. 14, quaddecagon. 15, pentadecagon, etc., etc., etc. I don't want to do that. You're responsible for the names 3 through 12. Anything higher than that, let's say we have a 57-sided polygon, we're just going to call that a 57gon. Instead of me trying to teach you how to say 57 using this weird Greek prefix thing. How many sides does an n-gon have?
None.
Nope. Good guess, though. Anybody else? How many sides does a 57gon have? 57. So how many sides would an n-gon have?
Anything you want it to have?
Beautiful, which we call n. Good. Don't get an n-gon confused with a nonagon. One has n, one has 9. Okay. And I know you know a whole bunch of different quadrilaterals, like a square, like a rectangle, like all those other things. But the general term for a 4-sided polygon is a quadrilateral. Questions? We're good? Polygon Sum Theorem. What does this mean? Well, we've done the triangle sum theorem already. What is the sum of the angles in a triangle?
180.
$180. Correct. Easy peasy lemon squeezy. We did that a long time ago. What we want to know, though, if I go back to this crazy picture, what's the sum of the angles in, let's say, that quadrilateral? What's the sum of the angles in that big honkin' magenta decagon? How do we find those? Oh, you got an answer?
Isn't it for every side you add plus 90 or 180 degrees? Possibly. Or am I off?
Interesting. I'm not going to tell you right or wrong, but I am going to ask you another question. Why? So let's suppose, I'm going to give you a hypothetical. Let's suppose I knew what the sum of the angles was in a pentagon. You're saying if I go to a hexagon, I just add 180 to that total.
Maybe.
But again, why?
Because you're adding an extra angle. And that extra angle adds a little more value to it.
Can you kids at home hear what he's saying?
Barely.
Barely. Okay, I'll have him speak louder from this point on. You don't have to repeat everything. You're 100% correct. Well, I don't necessarily like the way you explain the why, so I'm going to give all of you a different approach to this. So based on what we already know, the sum of the angles in that triangle is 180. Any triangle has a sum of 180. If we expand that, let's suppose I want to know the sum of the angles in this quadrilateral. I know nothing about the quadrilateral except that it has 4 sides. So I'm going to get sneaky. How many triangles? 2. Each of them have a sum of 180. So 180 plus 180, 360. Now I go to a pentagon. How many triangles? 3. Sum. You're going to need your calculators, by the way, if you want to bust out. Those of you at home, too, get your calculators out. You're going to be doing a bunch of calculations. 540. Okay, good. And we can keep going in order. So then a pentagon would go to a hexagon. We take this hexagon and say, okay, the hexagon is, what have I got there? 1, 2, 3, 4 triangles. Each triangle is $1.80. So that would be 720? Did I do my math right? Okay. That method is great, but what if we get kind of crazy here and I want to go all the way up to 57? I am not going to go from a triangle to a quadrilateral to a pentagon and keep working my way up. I want to be able to do this without breaking into triangles. Okay, so to do that, I'm going to make a chart here. N is the number of, where's my N? N, there we go, is the number of sides. Second column is the number of triangles. So for instance, 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. And I know that you're all pretty good on pattern recognition. So as I keep going, dot, 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 down to N, how many triangles? Bingo. Well done. So let's stop and make sure everybody follow that. Yes? Zoomers? We're good?
Yeah.
Good. I'll take that one yes as a yes. So this is what I'm talking, or what I was talking about earlier. On the next slide, I'm going to give you a formula for finding the sum of the angles, let's say, in a nonagon. If you just attempt to memorize or to apply a formula, you're going to miss that learning component that you're going to need to solve more complicated problems. Okay? So, let's go to the next slide. This is what we just did. Thank you, Daniel. Good job. And we get that formula. Capital S stands for the sum of the angles in a polygon. The other important thing to realize is I'm not saying how big any of those angles are. All I'm talking about is the total sum. Okay? So, I know I'm hyping on this, but I'm really trying to help some of you. What does this formula mean? Well, some of you are just going to write down the formula and just try to plug into it every time. But for those of you that are succeeding, you're going to succeed because you realize this is the number of triangles. By the way, that's not a hashtag. That's the abbreviation for number. And this is the angles in a triangle. Each triangle has a sum of angles of 180. So if we take the number of triangles that make up that polygon and we multiply it by 180, we will get the total sum. Any questions about the concept, Zoomers or Roomers? We're good? Have you done this before? Yeah? Okay, good. I'm guessing, well, maybe I'm wrong. Did you ever talk about where the formula comes from, or did you just plug and chug?
We actually talked about it.
Hmm?
We actually talked about where it came from.
Good. Kudos to your teacher. Who was your teacher?
Mrs. Grabowski.
I would know her. What grade are we talking?
7.
7th grade. All right. Awesome. Well, how can we make it more interesting? Well, we can do a couple things. We can work the problem backwards. Here's a polygon with a certain angle sum. How many sides does it have? Or we could start talking about individual angles. So what we're going to do is we're going to talk about individual angles, but before we do that, I honestly don't remember. Have we talked about what a regular polygon is? Does that sound familiar to anybody? Okay. That's good enough that we will talk about it. Regular polygon. By definition, equilateral and equiangular. All right, what do those two terms mean?
All the same sides, all the same angles.
Good. All equal sides, all equal angles. Okay. Example, you could have an octagon with 8 sides. However, if you have a regular octagon, it looks like a stop sign. And in fact, on this slide, right here, whoops, that is a regular octagon. Okay, so let's suppose we have a regular polygon. And you can see, by the way, what would a regular quadrilateral be called? What's a four-sided figure with all equal sides and all equal angles? Go.
Square?
Hold on.
Equilateral.
Yes. What's its other name? And who was that? Emily, was that you?
Yeah.
Yeah, it's a square. Okay. Equal angles, they're all 90 degrees, equal sides. And most of the time, if you say to somebody, hey, draw me a pentagon, they're going to draw a regular pentagon. If you ask somebody to draw you an octagon, they're going to draw you a regular octagon. It's just what we operate with. So remember what I said here. I have no idea about the angles in this regular, or in this quadrilateral, because it's just some plain old quadrilateral. However, if it's a regular polygon, I know that all the angles have to be the same shape, or same size, I should say, so therefore we can divide by the number of sides to get that angle measure for one of them. Okay, this only works if it's a regular polygon. If you don't know it's a regular polygon, then you can't use that. So, in other words, you take a square. A square is a quadrilateral. N minus 2 times 180 means the total of the angles is 360. It has 4 angles in it. 360 divided by 4 gives you 90. Okay. So let's do some examples. Find the sum of the interior angles in a nonagon. Notice it doesn't say regular nonagon. It just says nonagon. We are going to work with a lot of formulas. So one of the things I'm going to hype on today is how to show work. In a problem like this, I would like you to start with a formula, plug into the formula, and tell me the answers. I never like when an answer just appears out of nowhere. So go ahead and do that calculation. I'll take a drink. Am I losing my mind, or did I just hear the Old Spice jingle? Where did it come from? Was it in here? Oh, it was in the hallway. Okay. All right. If somebody actually whistled that, it was really good. Everybody's got to have a skill, right? At home, when you have an answer, give me a thumbs up. In the room, if you have an answer, raise your hand. Or when you have an answer, I should say. I know you're going to have an answer. Okay, good. Got 1, 2, 3, 4, 5, 6, 7. We'll wait till 10. You can put it down. It's okay. Good. Uno más. Got it. Okay, 10. Beautiful. Let's see. Olivia, your turn. What'd you get for an answer first?
1,260.
Say again, I'm sorry.
1,260.
Can somebody confirm? We have thumbs up all across the board. Beautiful. Now, the more important thing, Olivia. How did you get that?
I used the Polygon Sum Theorem. I did S equals 180 times 9 minus 2.
Math happens on your calculator. 1260.
Yeah.
Beautiful. Problems. Easy peasy? Good. Let's add another element to the problem before we go on to example 2. Suppose all of a sudden I said, now it's a regular nonagon. How big would one of the angles be? Olivia, what would I do to find that answer?
Sorry, can you repeat that?
Sure. Let's suppose I changed the problem and I said it's a regular nonagon. And I want to know the measure of one angle, not the sum. How would I find the measure of one angle?
You would do n minus 2 times 180 divided by 2.
No, not by 2. Right. Take this, divide by 9.
Yeah.
Little help, please.
140.
140 exactly?
Yeah.
Oh, nice. I didn't think that was going to be a nice number. Okay, so now on another step to help understand. Angle measures can be decimal values. I actually didn't remember what that is. It got a nice pretty answer of 140. You can have an angle of 32.667. What you can't have is n being a non-integer value. N must always be greater than or equal to 3, and it has to be an integer. You all remember what an integer is, yes? You can't have 5.5 sides. That doesn't make any sense. Okay, good. Thank you, Olivia. Problem number 2, somewhere in here. There it is. Let me get this mess out of the way. Okay, thanks for coming. See you. Nice weekend. No, just kidding. Okay. That figure, RSTU, might look like a figure you already know about. You might be thinking to yourself, hey, that kind of looks like a parallelogram. But we don't know what that means yet. We just know that it's a quadrilateral. So knowing that it's a quadrilateral, find x and solve for all the angle measures. Please. Okay, in an effort to save time, because I do want to give you a bunch of time to take a look at day 5 with your groups, I'm going to move forward. What do we know about all those angles added together? Good, they equal 360. Okay, so there's the answers, and here's how I solved it. I added up all those angles, set them equal to 360, and solved for x, and got 11. How did I get 55 and 125? I put 11 back into each of the angle measures. Don't make assumptions that you don't know are true. Don't assume that that's a parallelogram. Don't assume that it's anything other than what you're given, and that is that it's a quadrilateral. Okay? Questions? Moving on. 6 of the angles of a convex octagon are congruent. Each of the other 2 angles has a measure of 20 more than the measure of each of the other 6 angles. Find the measure of each angle. Holy smokes, what the heck is going on here? Well, I'm a visual learner, so I'm going to use this picture of a yellow stop sign. By the way, your fast fact for today, stop signs were originally yellow before they became red, believe it or not. I know that 6 of these angles, 1, 2, 3, 4, 5, 6, are all equal to each other. I don't know how big they are, so I'm just going to call them x, which is a common approach when we don't know the measure of each of the angles. The other 2 angles, can we express the measurement of those other 2 angles in terms of x? And if so, what would it be? Go.
You have the sides that are all congruent, or there's 6 of them, so it would be 6x. And the other 2 would be, you have 2 times x plus 20.
Good. So this would be x plus 20, and this would be x plus 20, because 20 more than is x plus 20. Good. Well, what do we know about all the angles in an octagon? I don't know anything. I have to do a calculation. N minus 2 times 180 equals S. Let's see. 8 minus 2 times 180. A little help, please. What's 6 times 180?
1080.
1080. Beautiful. I know that the sum of all these angles is 1080. Based on what Daniel was just telling me, I also know that it's 1, 2, 3, 4, 5, 6, 7, 8x plus 40. Does that make sense? We're good? Okay. I'm going to assume that you can all solve that problem. Remember, x and angle measures can be decimal values. N can never be a decimal value. And also notice that it doesn't say anywhere in the problem. In fact, it can't be a regular octagon. It's got to be some bizarre looking octagon. I don't know if I did the work on, I did. There's your answers, 130 and 150. If you solve for x, that's what you should get. Okay. Questions before I move on? Zoomers, any questions? If you don't have a question, give me a thumbs up, please.
Where'd you get the 150 from? Because I only got 130.
Once you find out what x is, by solving this equation, you plug it back in and you get it from that point right there by taking that x value and adding 20 to it.
Oh, okay.
Okay, good. Moving on. All right. This one you do on your own. Solve for x. Katie, let's go with you. How many sides?
6.
Good. What's the total sum of all the angles in a 6-sided hexagon?
720.
720. I'll trust you on that. I'm assuming you did n minus 2 times 180.
Yes.
For all of you, you'll start to realize that as you do more and more of these, you'll just know. A triangle is 180. A quadrilateral is 360. A pentagon's 540. A hexagon's 720. You might forget the other ones, but for now, we know, based on what Katie just said, it's 720. Great. What'd you do with that then?
I then added all of the angles that we have. And
Beautiful.
subtracted that to get x.
So you did x plus 110 plus 160 plus 130 plus 120 plus 90. Whoops, 90, not 9. Right? Did I get them all? 1, 2, 3, 4, 5, 6. Yeah. So what's x turn out to be?
110.
Can somebody confirm, please?
Yeah.
Beautiful. Okay? So it's a two-parter. What's the total of all the angles? How do I use that to solve for x? Well done, Katie. Thank you very much. I got 110 too. Excellent. Same. Okay. What are we? Let's see. We're just going to be straightforward. First of all, let's talk about an exterior angle. Okay. What is the exterior angle of a triangle? An exterior angle of any polygon is an angle that forms a linear pair. Now we're going way back, remembering what a linear pair is. It's an angle that forms a linear pair with the interior angle of a polygon. Okay, how about English, Reedy? Okay, let's look at this. Here's a triangle. Let's take that angle there. I want the linear pair to that angle. Well, you'll recall a linear pair is adjacent and supplementary. So I'm going to extend this puppy. And this angle is what's called an exterior angle. Linear pair to an interior angle. Come over here. That's an exterior angle. Come over here. That's an exterior angle. Triangle has 3 sides. Therefore, it has 3 angles. Therefore, it has 3 exterior angles. Pregunta.
So can you take the baseline and go left as well?
You could. Okay. If what I'm understanding you're asking is you're saying, couldn't I do that? Yes. There are technically 2 exterior angles, but what do we know about those 2 angles?
They're equal?
Yeah, they're right. So we just deal with the one of them. One per angle. Okay? So what happens if I add up these 3 angles? Angle 1, whoops, that's an eraser. Angle 1, angle 2, and angle 3. Something weird happens. Regardless of the shape of the triangle, if I add up angles 1, 2, and 3, I will always get the same value, and that value is 360. Okay? How do we know that? Well, we could go through a long proof, but if we look at an equilateral triangle, I know that these are all 60-degree angles. Therefore, the exterior angles are all 120. 120 times 3, 360. Okay, that's great for a triangle, but what about other shapes? Okay, well, what about a square? What's going to be the sum of the angles in sum of the exterior angles in a square? Let's see. Square 90, 90, 90, 90. Exterior angles also 90, 90, 90, 90. 4 times 90, 360. Ooh! No formula, just a value. The sum of the exteriors in a triangle or any in any polygon is 360. Doesn't matter how many sides, doesn't matter what shape. If you add up all those exterior angles, you're going to get 360. So that leads to an interesting scenario. Let's suppose I want to find, let's forget about the problem. Okay? Well, I lied. Let's do it quickly. Exterior angle in a regular decagon. The total is 360, 10 equal angles, each angle is 36 degrees. Okay? I want to change the problem. I want to find the measure of that angle. And I'm going to show you 2 different ways to do it. We've done one method already. And that is, it has 10 sides. So the sum is n minus 2 times 180, which is 10 minus 2 times 180. A little help, please. What's 8 times 180? 1440? 1440 is the sum. There's 10 of them. So if I divide by 10, I get that angle measured to be 144 degrees. Okay, before I move on, is everybody good with that approach to the problem? We're good? Okay. I'm going to show you a different way to do it. If you like this other method, great. If you don't, that's okay too. Answering this problem, I know that this exterior angle right here is going to be 36 degrees. Why? Because 360 divided by 10 is 36. So the exterior angles are all 36 degrees. And one of the things that we said way back when, I think I erased it, was that an exterior angle and an interior angle form a linear pair. What does it mean to form a linear pair? They add up to 180. So if I do 180 minus 36, that gives me 144. Okay? So I'm going to do this again with a weird shape. Let's take Let's take I don't know. I need it. Mia, what's your house address?
707.
So, okay. Really?
Yeah.
Does anybody live in a house with an address of just 2 digits? Because that could get really ugly. No? Anybody at home? Is your house number like 24 Smith Street or anything like that? All right, we're going with 707 then. I've got a regular 707 gone. All right, I'm winging it here. I would like to know what is the interior angle measure of one angle in a regular 707 gon. We're going to split the screen in half, and I'm going to do 2 different methods. Okay, the first one says 707. Well, that was weird. Let's try that again. Where'd my screen go? There we go. Oh, I lost it. Okay. N minus 2 times 180. 707 minus 2 times 180. What's 705 times 180? 169,000? 126,900 degrees. Holy guacamole. Divided by 707, because they're all equal, gives me an answer of
179.
Oh, sorry, yeah.
179.5. Okay? Now, that should kind of make sense if you visualize what's going on. We have a polygon that has 707 sides. It's going to be pretty close to a circle. Okay, so that's one approach to it. However, the other approach would be to say, okay, if the sum of all the angles around the outside is 360, and there's 707 angles, then each exterior angle would be, what's 360 divided by 707? 0.51 degrees. Then 180 minus 0.51, sure enough, 179.5 degrees. Do you have to do both methods? No. Do you have to pick one of them and run with it? Yes. But again, what you should be striving for is not a blind memorization of a formula, because these concepts break down if that's how you try to approach the problem. Okay? Beautiful. Did that already. We're not going to do this one because I want to give you enough time to work. But 1, 2, 3, 4, 5. Doesn't matter how many sides. All the exterior angles add up to 360. 2x plus 2x plus 4x plus 3x plus x equals 360. Solve for x. Plug it back in and you get your answer. Okay? All right, we're done. Questions?